integration of cos of root x divided by root x into dx. As we observe, cos of root x is a composite term in which in cos function x is replaced by root function. So we are going to put root of x is equal to t and differentiate this with respect to x, as derivative of root x is always 1 upon 2 root x into dx is equal to dt. Now observe, in integration the remaining term without composite term is 1 upon root x into dx, and we are here find the relation between dx and dt in which 2 is on left hand side in denominator. So we have to find only 1 upon root x dx. So we adjust 2 on right hand side. So we get 1 upon root x dx is equal to 2 dt. Such a type of simple adjustments are required in some examples of substitution method. So remember this. So I will become integration of the composite term in which root x is a t. So cos of t into the remaining term will be root dt. Now 2 is a constant, take outside integration. So we have to take only integration of cos of t, as integration of cos is a sine. So integration of cos t is a sine t plus a, and finally replaced by t root x, we get the answer to sine root of x plus c. Okay, next example is integration of cos cube x into sine of x. Now here in this example also we can define composite term is a cos cube x, in which term of x is a cos of x. So we put cos of x is equal to t, and its derivative with respect to x is a minus sine of x dx is equal dt. But as you observe, remaining terms without composite term is sin x dx. So we have to adjust sin x dx in this relation. So we take minus sine on right hand side. So sin x dx is equal to minus dt. See the simple adjustment. So integration will I is equal to the composite term will become t cube, and sin x dx is a minus dt. As it is negative, we put the bracket. If minus, take outside integration, as it is a constant. So integration of t cube dt, and integration of t cube is always t raised to 4 upon 4 plus c. And finally resubstituting the value of t, that is cos of x raised to 4 divided by 4 plus c. Okay, now next example. The example is a e raised to x into x plus 1 divided by sine square x e raised to x. As you can observe here, the composite term is in denominator, that is sine square x e raised to x, in which actually a bracket is a function of x which is put into trigonometric sine function, and this sine function is put into power function, that is f of x, f of g of x raised to 2 is a form of this function. So in power function there is a composite term, but we are going to put here only x e raised to x is equal to t, that is term of x. Now this term of x is in product, so we have to differentiate this with respect to x by product rule. As you know, the two terms are in product, so first term is constant, derivative of second term e raised to x is e raised to x, then put plus sign. Now e raised to x is the second term which remain constant, and derivative of first term is a 1, x has a derivative 1. This is a derivative of x e raised to x by product rule multiplied by dx, as these are terms of x, and derivative of t is equal dt. Now e raised to x is a common, so in bracket remain x plus 1 into dx is equal dt. Now we have to replace in composite term x e raised to x is equal t, and this product as a dt. So I will become, now see, the composite term is in denominator, so always first put the composite in composite term of x. So we put numerator as a 1, and in denominator x e raised to x is equal to e. So term will become sine square t into dt, as this is a only dt. Now 1 upon sine is always cosec, so 1 upon sine square is equal to cosec square into dt, and derivative of cosec square is a minus cot t plus c, and final answer will be minus cot of x e raised to x plus c. Okay, the next example is similar to this example. which is a x minus 1 into e raised to x divided by x square into cos square e raised to x upon x into dx. Here a composite term contained in denominator, and in which a term of x is a e raised to x divided by x, which is a quotient. So we have to differentiate this term by using quotient rule as. So denominator remain constant, derivative of numerator is e raised to x, then sign is a minus, numerator remain constant, derivative of x is a 1, and remember we have to divide it by this by square of denominator, that is square of x is a x square into dx is equal to dt. Now e raised to x is a common in numerator, so in numerator we get bracket x minus 1 into e raised to x divided by x square into dx is equal to dt. Now you can observe integration. The remaining terms are without composite term is x minus 1 e raised to x divided by x square dx is equal to dt, which will become dt. So I will become integration of, as it is in the denominator composite term, so we have to put it in denominator. So we take numerator as a 1, and in denominator term of x is equal to t, then term will become cos square t is equal to dt. Now 1 upon cos square is equal to sec square t, and derivative of sec square t is always tan of t, and we get the final answer by substituting t as a e raised to x upon x is tan of e raised to x upon x plus c. Okay. Now next example, 2 raised to tan of x divided by cos square x. Now here we have to put tan of x, but derivative of tan x is always sec square x, and sec square x is a 1 upon cos square x. Here sec square is a given, but in form of 1 upon cos square x. So we first take simplification in integration, as 1 upon cos is equal to sec, therefore 1 upon cos square is equal to sec square x. Now we can put here now tan x, as derivative of tan x is in integration, and which is a sec square x. So sec square x dx is equal to dt. Now integration I will become 2 raised to t into sec square dx is equal to dt, and 2 raised to t is the exponential function, has the integration 2 raised to t upon log of constant 2 plus a, and finally t is replaced by tan of x. So we get 2 raised to tan of x divided by log of 2 plus c. Next example is evaluate integration of log of tan x by 2 divided by sin x. Now observe this integral. Here the term of log is a log of tan x by 2, which is in form of composite. We have to put term of logarithmic or inverse function as it is. So we are going to put here direct log of tan x by 2 is equal to t. In earlier example we have gone through, if f of 0 of x is given, that is in term of composite form, composite function is given, then we put only term of x. As here is a term of x is a tan x by 2, but this is a logarithmic function, so we have to put it as it is, and then we have to adjust dx and dt. For that we take differentiation with respect to x, as this is a composite term. By using chain rule, derivative of log of f of x is always 1 upon f of x into derivative of f of x, that is f dash x. Similarly here derivative is 1 upon tan x by 2 into derivative of tan x by 2 in multiplication with respect to x. On right hand side t has a derivative dt. Now 1 upon tan x by 2, tan is always sine divided by cos, so sine x by 2 divided by cos x by 2, and derivative of tan x is always 1 sec square x by 2, as coefficient of x is 1 by 2, so multiplied 1 by 2 into dx is equal to dt. Now simplification, actually 1 upon sine, the value of sec is always 1 upon cos, so value of sec square x is equal to cos square x by 2 into 1 by 2 into dx is equal dt. By cancelling square to cos x by 2, we get in denominator numerator 1 1 1, that is multiplication by numerator 1, and in denominator 2 times sine x by 2 into cos x by 2 into dx is equal dt. As we know, half angle formula of sin x is equal to 2 times sin x by 2 into cos x by 2. So this denominator become 1 upon sin x into dx is equal to dt. Now we have to put the term of log tan x by 2 is equal to t, and 1 upon sin x dx, which is in integration, it become dt. So integration becomes I is equal to observe this integration of t, and this will replaced by dt, and the integration of t is always t square by 2 plus c, and finally we have to resubstitute the value of t. The value of t is a log of tan x by 2 bracket square divided by 2 plus c. Okay, now next example, I is equal to integration of tan inverse of e raised to x divided by 1 plus e raised to 2x into e raised to x dx. Similarly, in this example also, we have to put differentiable term, that is inverse trigonometry term, which is a tan inverse of e raised to x, which is in composite form. So we have to differentiate this with respect to x by chain rule. The derivative of tan inverse x is always 1 upon 1 plus x square, but x is replaced by e raised to x. Therefore, its derivative will be 1 upon e raised to x bracket square, and by chain rule we have to put derivative of e raised to x into multiplication, as t has a derivative e raised to dt. 1 plus e raised to x in raised to 2, that is e raised to 2x into derivative of e raised to x, e raised to x is equal to dt. Now I will become the term of inverse trigonometric function is a t, and this all is dt. Now integration of t is a t square by 2 plus c, and finally put the term of t tan of e raised to x bracket square divided by 2 plus c. And last example, here we have to put 1 upon x into log of x into log of log x. See, there is a logarithmic term log of x and logarithmic term in composite form. So here we are prefer to put log of log x, and derivative of log x is 1 upon x log of x. So this integration will become 1 upon t into dt, and this 1 upon t has the integration log of t plus c, and finally will be answer log of t is a log of x plus c.